Hi everyone, welcome to the first video for this week. So this week is the first official week of school at home, at least as far as grades go and everything. And we're talking about April 13th through the 17th, right? So you should be viewing this, the first of the 3 lessons for the week for that week, 13th through the 17th. So what we want to do is we're going to pick up exactly where we left off in school, and I'm going to do my very best to give you pretty much the same education that you would have had at school, just now at home. So we're going to do as much as we can for that. So we left off in our chapter in physics, talking about all kinds of different types of motion and everything for that, different forces. So we touched on Newton's 3 laws of motion in school, where you built those Newton pyramids and everything, but we never formally went through the 3 laws. So for today, what we're going to do is go through Newton's first law. And then you can imagine, the next lesson that we're going to do this week will be Newton's second law, and followed up with Newton's third law later this week. Right? You can do all 3 lessons today, or you can kind of space them out. But remember, they've got to be done this week. Because we're now in grading mode, for each one of the 3 lessons, there's going to be a short quiz that you're going to take that's going to help you with your grade and give you some grades and everything like that. So you want to make sure that you follow along and do all the things that are required for each one of the lessons. Take the quiz, and the quiz should be fairly simple as long as you're following along with everything. So let's get started right away with Newton's first law of motion. Right, so for Newton's first law of motion, here we go. Just like I was telling you before, there is no one steadfast rule. This is Newton's first law, and everybody in the world has the exact same definition for it. Now, everyone in the world has the same meaning for it, but we word it differently. So if you go in one website, you might find one definition for Newton's first law, and the 300 other websites you might go to might have it worded differently, but it's going to mean the same thing. So here is a really common example for Newton's first law. Objects at rest tend to stay at rest. And so I've got my Newton's cradle right here, which is perfect for describing Newton's laws of motion. And so according to the first law of motion, I've got my mini Newton's cradle going right here. Hold on for it. Well, because I just moved it, now it's moving. But imagine if the Newton's cradle was perfectly still. Well, according to Newton's first law of motion, it's going to say objects at rest stay at rest, right? Or the other side of this is objects in motion tend to stay in motion, right? And so again, that's where Newton's first law comes in. So if we go back to the Newton's cradle, probably the best, most common way to describe Newton's 3 laws of motion right here. Well, the first half of Newton's first law is objects at rest stay at rest. And so you can imagine if we just kind of keep the Newton's cradle sitting here and we wait carefully, it stays at rest. It's not moving at all. And if I wait a few more minutes, well, nothing's happening. It's still at rest, right? That's Newton's first law right there. It's amazing. Right? Objects at rest stay at rest. Now, objects in motion stay in motion, and that's where you get into the moving part of Newton's cradle, right? If I pull it back and create some motion, well, it's not that the reaction happens one time. It keeps going over and over and over and over, right? So it keeps happening over and over and over again. Now, it won't go on forever because here on Earth, there's all kinds of friction, right? There's air molecules bumping into these little guys. Every time one of the little tiny metal balls bumps into another one, that creates friction and they lose some energy there. So it's just one example, but here on Earth it's very hard to have a perfect example. But for Newton's first, that is Newton's first law. Now this is the official one that I've given you right up here for Newton's first law of motion. The Mr. Jackson version is this guy right here. Stuff keeps moving how it was, right? So we did the Newton's cradle, kind of like the picture right here. Did you ever play with a top when you were a little kid? Right? There are lots of versions of tops, but a top shows Newton's first law of motion also, right? If it's just sitting there on the counter and it's not moving, no one's playing with it, well, it keeps doing what it was doing. It just sits there, just like the Newton's cradle did, right? But if you kind of pump it and you get the top moving really, really fast, so it's spinning around and around and around faster and faster and faster, well, there you go. Now it wants to keep going round and around faster and faster. That's Newton's first law right there. And that's what we want to quick talk about today for us. So there are tons of examples, right? Normally in class, I have a big globe and I'll put that on the counter and I'll spin it kind of like the top right there, and it spins faster and faster and faster. I don't happen to have a globe with me here at home, but what I do have is a little mini pool ball, right? And so for this mini pool ball, what we can do is if I put it down here on the counter, kind of like the top idea. If we spin it, oh, hold on here. Well, there you go. It wants to keep spinning and spinning and spinning and spinning, right? Again, it doesn't keep spinning indefinitely forever because there's friction between, well, I've got my giant penny here for it, and, you know, and the actual pool ball, but it does spin for a while because once it's in motion, it wants to keep that motion, wants to keep doing what it is doing. Similar to my mini pool ball, I've got my nice penny here. Doesn't everyone have a penny like this guy, right? And if I spin the penny, well, sure enough, it wants to keep spinning, 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 spinning. Okay, that's enough of that. But you get the idea, right? It wants to keep moving, right? That momentum that's in it, it wants it to keep going and going and going and going, right? Because it's moving for it. Gyroscopes, well, normally in school I would show you a gyroscope, but all a gyroscope is, it's really like a top. It's basically a scientist version of a top, and it'll do the same thing. It keeps spinning and spinning. Sometimes it might spin for 2 or 3 minutes. It just spins and spins and spins because it's really heavy. It's got a heavy mass of weight in there. So all those atoms, all that mass just wants to keep moving and moving and moving. That's Newton's first law. Right? Or the Newton's cradle, just like I showed you here, my kind of old busted up, you know, Newton's cradle that we have right here. Things keep wanting to do what they were doing. Let's see here. So normally you'd fill in your workbooks the word inertia for this, but for today, just kind of follow along for it. Right? Inertia is what we call Newton's first law of motion. In fact, if you looked up all those definitions for it, you probably found it said, you know, Newton's first law of motion is often called the law of inertia. Right? This is an object's tendency to want to resist changes in motion. A perfect example of this is a roller coaster, right? Everyone's probably ridden a roller coaster at one point, or at least seen a video of it, right? So a roller coaster sits in the train station, you know, where you get on the roller coaster and you get off the roller coaster. Hopefully you don't barf or anything like that. But if the ride is just sitting there, right, and nothing else happens to it, the train for the roller coaster is just going to sit there. I mean, for days, weeks, months, years, it's just going to sit there and sit there and sit there until some other force is applied to it. Now, the force that's applied to it is usually it clicks onto a chain, or there's some kind of force that pushes it up the hill, propels it up the hill. As it goes higher and higher and higher, it gains more and more potential energy, is what we call that and everything, until it gets to the very top and it has the most. But then what happens is at the top, it goes over the hill and starts going down, right? And as it goes down, it gains more and more and more inertia, more motion, or speed gets into that roller coaster, so much so that now it wants to resist stopping, right? As much as at the train station, it wanted to just stay there and not move. Now as it's going down the hill, it wants to keep going faster and faster and faster, and it wants to keep that motion, so much so that even when the hill pushes it back up, it's got so much inertia, so much energy, it just flies right up that hill, goes around loops, turns, swerves and everything like that, and hopefully people don't barf all over it, right? But that's inertia. That's, you know, it wants to change. It doesn't want to change its motion. It wants to keep whatever motion it has, whether it's still or it's moving. Let's see. Oh, here's another example. Here's the opposite, right? Here's an example of a really heavy object. It's got no inertia. It doesn't want to move at all relative to the things that are around it. So much so that if you try to push on it, well, good luck with that. It's not that you couldn't push a car like this, but it would take a great deal of force because there's no motion going on there for it. And there are other examples, bowling balls, right? Once you give a bowling ball lots of inertia and it goes rolling, where's my mini bowling ball, right? It goes rolling down the aisle, right? It's got lots of inertia to it. So much so it can make it all the way down the bowling aisle and, you know, knock over a whole bunch of pins and everything. About roller coaster, or not roller coaster, other rides other than roller coasters and amusement parks, right? They operate on Newton's first law too. Let's say if you've ever ridden this big swing ride right here, right? As the people are swinging around and around and around on the ride, the motor doesn't have to be very big on this ride because all the ride needs is just a little push of energy all the time, consistently, right? And it gets going faster and faster and faster. Then once the ride's actually going and in motion and they're all spinning around and everything like that, well, it doesn't take very much energy at all, right? Because it wants to keep going in that same motion, right? Same thing when you want to stop it. Right now, you've actually got to apply brakes to it because it wants to keep going in that motion over and over again. So a lot of amusement park rides are perfect examples of Newton's laws, especially this first one. How about sports, right? Are you interested in sports? Pretty much all sports rely on Newton's laws of motion, especially this first law, right? Whether you're throwing a ball or, you know, propelling a ball some way, kicking it, right? Whether it's your own body and you're jumping, throwing, or tossing, whether you're riding a bike, right? Once the object's in motion, it wants to keep going, right? You throw a football and it just keeps going and going and going and going. Now, not forever, because there's friction involved, right? It's bumping into the air, gravity's pushing down on it and everything like that, but it wants to keep going. If you jump, right? If you're a long jumper, right? You jump and your body keeps going through the air, right? Because of Newton's first law. Things want to keep doing what they were doing for it. Now, let me jump over and we'll get into talking about the activity that you can do for today. And there are a couple of videos for you to watch before you take the quiz. Your assignment for today is relatively simple. You're going to need a counter or a desk, a piece of paper, and some kind of cups, preferably not glass ones for this. Now, according to Newton's first law of motion, right, if you have some cups and they're sitting on the piece of paper and you don't do anything, they will stay there, just like we talked about a moment ago and everything, right? And if you took one cup, put it on the piece of paper, and you pulled it quickly, well, the cup does usually move when you do this, but it's not like it stays with the paper, right? Because what I do is I give it a quick little impulse pull, and so the cup stays there, right? That's Newton's first law of motion. Objects at rest tend to stay at rest. And so since the cup is here and it's at rest and it doesn't want to move, right? If I give a quick little impulse of pull, it wants to stay still, right? That's Newton's first law. So maybe you can figure out where this is going, right? Your assignment for today is to kind of practice Newton's first law of motion, right? If you pass the one cup pull, well, what happens if you put a couple cups on here? Right? If I put a couple cups onto the end of the piece of paper. Now, one trick to this is put them at the end of the paper. Don't put your cups over here at the middle of the paper, because as you pull it, they'd have to slide past all this friction, and that's more chances for them to move, right? But if you do that and I pull it, can I pull it and keep the cup still standing? Yes, I can. So how good are you, right? After you get through, just a couple cups, see, can you add more cups and more cups? How many cups can you do and still get it to pull? So again, don't use some kind of cup that's going to break. Maybe a plastic cup or something like that. In fact, one trick to this is the heavier that the cup is, the more mass that's there, the more mass or the more atoms that are inside the cup, well, the more stuff you have that's trying to resist change, and the easier it actually is. A tiny little light plastic cup like this is relatively hard to do for Newton's first law. If you can have like some kind of plastic drinking cup that's a lot bigger, it actually is a little bit easier. Right, the other thing is make sure the material that you're using is kind of a smooth material that you have for this and everything. Okay, so that's the example for today for Newton's first law. After you watch this video, there are going to be a couple other video links for you to check out really quick. Then once you've done your homework for the day and everything, you can take the quiz that's going to be attached to this, and then you'll be done with the first lesson.